Okay, so we're on 5B, which is now looking at the Chinese postman, and I'm going to try and do it on the same thing I've done previously, but I am going to change the colour in the hope that it makes it a little bit clearer for you watching this. So the question then is, each day a police car has to drive along each road at least once, starting and finishing at A. So for an optimal Chinese postman route, find the driving time for the police car and state the number of times that the vertex B would appear. So it's classic Chinese postman without too much difficulty, hopefully. So the first thing we have to do with the Chinese postman is decide what are our odd nodes, and this is the good one. So we've got 2 here, we've got an order 3 here, 1, 2, 3, 4, 5, 6. There's order 6 there, 2 there, 1, 2, 3, 4, 5, 5 there, 2 there, 1, 2, 3, 4, 5, 6, 6 here, 2 there, 3 there, 4 there, 6 there, and 1 here. Okay, so our odd nodes are definitely A, C, L, and G. Okay, that's the first thing to do, is find the order of the nodes. So how many lines go into each node, how many arcs, and those are your odd nodes. Write those down, you'll get a mark, or at least you'll have an idea of what you're doing. Then you need to pair them up. You need 3 sets of pairs. So I'm going to start with A going with C, and A going with L, and A going with G. Okay, that would be always my suggestion to start. So if A goes with the C, then you've got L and G left. If A goes with L, you've got C and G left. And if A goes with G, you've got C and L left. Okay, so the idea of that is makes it quite clear. In this first place here, I'm going to put whatever the route is for A and C. So, where is A? A is there, C is up there. The shortest distance to get between them is going to be travelling along here and up there, I believe, so that's got to be 12. Okay, A to L is down there, so that's 7 and 4, that's got to be 11. And A to G, which is really what we did already, it's got to be 21, hasn't it? Because, of course, Dijkstra finds the shortest route between 2 points. Right, L to G, where is L? Is 15 then to G. C to G is also 15. And C to L has got to be 5 plus 4, I would have thought, yeah, which is 9. What you've got to do is be absolutely vigilant and very careful, just in case there's an alternative route around here, but because that's 5, that counteracts that one. That's 4 and that's 6, it counteracts going a different way. But you really need, and a lot of the time they will try and catch you out that way. So adding up, I have got 27 for this one, 26 for this one, and 30 for this one. Okay, so they've already given me that my minimum time, these are all times, is 134. I'm going to add on the shortest one in this case, which is going to be 26. So I'm going to add this one on as the shortest route, which means I've got a minimum of 160. Good. Okay, the next part of the question, hopefully, so find the driving time for the car. So the car would take 160 minutes to get around that, with repeating those routes to make them even to get back to A. State the number of times the vertex would appear at B. Right, so if we're using this, we need to think how many times you're going to be at B. B is here, okay? So how many times are you going to go through there? Well, I did A to L. So A to L, we would add in, it would actually go from there to there and then there to there to get A to L. And C to G is over there. Well, C goes to D, and then D we know goes to K, and K we know goes to G. So that part doesn't matter. So where this was a 6-node junction, B is now an 8-node junction. And by having 8 nodes, it means that you go into the B and out again, which means we visited it once. Then you might go in and then out again, and then in and then out again. So in actual fact, you only travel through it, oh, and another one for 4 times. So that you would travel through it 4 times if it has 8, if it's order 8, you would travel through it 4 times.